Good morning. My name is Jesse Caulfield. I'm the president of Keybridge Global. Most of you probably know us as one of the certified whitespace database administrators here in the United States. We offer and operate two versions of a whitespace portal. The whitespace portal, the community whitespace portal, is a free portal, which we offer as a part of the undertaking for as a whitespace database administrator. We also have an enterprise version, which is essentially a souped-up version of the former, which is particularly popular with users who have very complex radio environments and need to register those for protection. The reason why I bring that up is one of the things that we did when we built our portal was we started with a set of APIs. We started with a database, then we wrapped a set of APIs, the engine essentially to run a whitespace database on top of that, and then we used those APIs to build our portal, and that's the approach that we've taken from the very beginning. Start with the data, build an API, and then build a really nice user interface on top of that. This API we offer, or rather is used for a number of carrier resources. For example, we've built some whitespace client software that accesses our APIs, the Spectrum data, or rather the data itself. And then in addition to the whitespace, one of the things, essentially a separate development that we had undertaken in parallel with the whitespace database was spectrum monitoring, partially to characterize the whitespace spectrum for the benefit of the new unlicensed users who could get essentially two versions of reality. One version was what the database saw, which is essentially a binary, there's something in the band or there's not, and then there's the empirical evidence that there is something in the band, and it may not be suitable for use, even though it may be legal for unlicensed operation. So very early on, we recognized that while whitespace may be available for use, it may not be suitable for use. And we decided to start developing a spectrum monitoring solution to characterize that spectrum for the benefit of our users, both licensed and unlicensed. The licensed users want to know if an unlicensed user is perhaps encroaching, and the unlicensed users want to know, for example, if the licensed spectrum stops at the border or doesn't. We offer this as a series of data, raw data, and databases. We have a fairly substantial database matched in the white spaces by our peers, the other database administrators. We also pull in unlicensed transmitters wherever we can find them. We try to characterize those as well, not only in the white spaces, but in essentially every band that we can address. We also have databases of antenna profiles for the benefit of our users for their own network modeling, tower sites, which are, for the most part, available from vendors as well as government sources. A little bit of cloud for marketing purposes. Everything is in the cloud. Part of the API that we found is especially interesting is providing visualization, and that's essentially taking this data, which is primarily, or for the most part, geolocated or geotagged, and allowing our users to map it. Right? If you can take in a lot of information very quickly when you map that information. So at its core, mapping and geolocation or geotagging is integrated at a very low level into the databases themselves, into the APIs, into the query mechanisms, into the APIs as well. So you can start with a frequency, you can start with a location, you can start with a general area to query the database to look for that information. And then you can visualize, depending on the user interface, you can either collect that information in its raw format, according to your query parameters, or you can visualize it using our mapping API. And then modeling. So I mentioned earlier the database and the empirical versions of reality. So we have developed and incorporated into our API set a series of path loss models. You've probably seen these pretty maps, where these pretty heat maps. We have a series of algorithms where we take empirical data and we match it against predictive models, and we use that to essentially auto-correlate and correct the area path loss models to increase the precision, I guess you could say, well, not the precision, increase the accuracy so much as we can. And here are a couple of examples. Urban environments, some rural environments. These are some pretty heat loss maps, and most of you have seen these, so I won't take too much time to explain them. But the concept here is you can take some statistical points, some empirical measurements, and that will essentially allow you to adjust the topology of your path loss to improve its accuracy over some space. Some mapping. These are some pretty screenshots taken from our white space database. What you see here are point sources, so these are transmitters. The lower right-hand corner is a public safety network in Los Angeles. You can see there are quite a few nodes there. What we're showing here are the protected service areas. What we're not showing here are the overlays of the predicted as well as the empirical radio propagation, but the two, taken together, the two are very important. And then here's a pretty print of a waterfall chart that you've seen this before. This is sort of the meat of why, or I guess the substance of why I'm here. What we've done is we've taken this spectrum monitoring solution and we've integrated it into our databases. So, for example, we've taken the peak detection algorithms, and since we know where the sensors are, we correlate those with known transmitters. And when we don't know where the transmitter is, well, we know, or rather, when we don't know what the transmitter is, we've identified something, an unknown point source, and we can typically correlate it to some geographic area and identify the general geographic area of what those are, depending on essentially the constellation of sensors. Another interesting point here is the lower right-hand corner, you see the waterfall chart. This is a graphical output of the raw data. Now, we store the raw data, and for our interests and our customers, they're primarily interested in just, is there energy in the band or not? But we actually store all of the data. Now, our focus is on the sensor, right, very low-cost sensors, and data collection and data storage, and not necessarily on sophisticated analysis of the data. And for that reason, that's the exact reason why we surface all of that data to our users through an API, so that they can either download the data in bulk and crunch it on their own workstations, or work with us to integrate some algorithms on the server side and we can crunch it for them. And that's what I'd like to talk with you about at the demo. There are a couple other slides here, but they're really more relevant to white spaces.